So we are in Chapter 22, Fiscal Policy is Summing Up. And within this chapter, we are in Part 2, the government budget constraint, deficit, debt, spending, and taxes. So let's switch to slide number 25. And here we talk about once more the government budget constraint and the equation which we derived so far. So on the left hand side we have the stocks of bonds outstanding in period T. This depends on the stocks of bonds outstanding 1 year before times 1 plus the real interest rate, and then the primary surplus or deficit G minus T. We will modify this equation in several steps, and in the end I would like to derive this equation here, and on the left hand side of this equation we have a term which can be interpreted as the change in the ratio of debt to GDP. So here it is a case that we have bonds over GDP in period T, and then we subtract bonds over GDP in T minus 1. So we have the change in the debt to GDP ratio. How do we get from this equation to that equation? It will be the case that it needs several modifications. So in the first step, it is the case that we have to divide by yt. So we are dividing the first equation by yt. So we have a yt in the denominator here, a yt in the denominator there, and a yt in the denominator there. This can be rewritten in the following way, that we multiply through this term by 1, but not a normal one, but we are multiplying through by y minus t y, and then as a time index t minus 1 divided by y t minus 1. So the red term here is a simple one, and we sort the terms in a way that we can use them afterwards. This is the same expression as before. So let's assume that GDP grows at a constant rate equal to G. So therefore the term yt over yt minus 1 is equal to the growth rate G. This might be, for example, 2%. But in this equation here, it is not the case that we have yt divided by yt minus 1, but it's the other way around. So we have to compute the reciprocal value of this term. So in case that this relationship holds, then also yt minus 1 divided by yt is equal to 1 over g. Now we can use this term 1 over g and insert this term here in this equation. Let's do so. We have 1 over g in this relationship here, and it reflects this term. This term can be approximated by equation 11. So we can, instead of writing g in the denominator of this fraction, we can also subtract g here. In case that you are in doubt, you have to look in the appendix. There you can find the rules why this is possible to write g in brackets. So in the next step, I would like to split up this bracket. So I would like to split up this bracket in the following way, that we take the 1 out, 1 times bt minus 1 yt minus 1, which is here, and then we have only in brackets r minus g. In the next step, we write bt minus 1 over yt minus 1 on the other hand side of the equation. So this goes to the left hand side and pops up here with a negative sign. And then we are already done. So the left-hand side can be interpreted as the change in the ratio of debt to GDP. Now that we have derived this equation, we can come up with an interpretation of this relationship. So the increase of the ratio of debt to GDP is larger the higher the real interest rate. So in case that R is higher, then of course the term on the left-hand side will increase faster. The increase of the ratio of the debt to GDP is the larger, the lower the growth rate of output. So in case that the growth rate G is very low, then also the left-hand side will increase faster. The left-hand side will also increase faster the higher the initial debt ratio. So in case that a country has a high ratio of debt to GDP, then also it will be the case that this ratio will grow faster in the future. And the last term, this is the ratio of the primary deficit to GDP. Of course, a country which is running a government budget deficit will see this debt ratio increasing over time. In the textbook, there are some passages which are related to the question, how did countries decrease debt ratios after World War II? In the first step, it is mentioned that these ratios declined after World War II, and these declines in debt were not mainly the results of primary surpluses, but the result of high growth and sustained negative real interest rates. But when you look at these kind of chapters, it is a case that we cannot really understand why this is the case. For example, they present this table here, and in the text it said, now look at the growth rates and the real interest rate in columns 4 and 5. But this table only has 2 columns, and the growth rates and the real interest rates are not given in this table, and therefore we cannot prove whether the previous statements are right. Also, when it comes to table 22.2, there are some mistakes. For example, in the text it said, in Ireland, it increased by 83 percentage points from 25 to 108. But when you look at this table and you look at the row for Ireland and the column B over Y, then you can get here that the B to Y ratio for Ireland is equal to 87 and not 108. So I don't know, the text does not fit to the tables, and therefore, I would like to come up with a kind of warning. So do not read these sections, how countries decreased their debt ratios after world wars, and also don't read the section, the recent evolution of the debt ratio in some European countries. So, in the next section, I would like to talk about the Ricardian equivalence. What is that all about? Let's once more have a look at scenario A of our numerical example. There it was the case that the government was decreasing taxes in year 1 by 1 unit and financed this by increasing taxes in year 2 by 1.1 units. Let's assume that the government announces this kind of policy. So the government is decreasing taxes in year 1 and is increasing taxes in year 2. Let's furthermore assume that private households believe the government. So they believe in the announcement and they believe that the government will stick to its words. How would a household react in this situation? In year 1, they suddenly have to pay lower taxes, but they also know that in the next year they have to pay higher taxes. Therefore, when a private household wants to smooth consumption implies that they want to consume the same amount or almost the same amount of goods over time, then it makes perfectly sense to save the 1 unit in taxes in year 1 to earn the real interest rate R on it so that the private household can pay the taxes in year 2. So when the government announces and performs this kind of policies and decrease the taxes by 1 unit in year 1, the private household will save the money, will not consume it, so that the private household is able to pay the taxes in year 2, to pay the taxes of 1 unit plus the interest rate R. So it is the case that when the private household anticipates this behavior or believes the announcement of the government, this kind of policy does not affect the real economy at all. It is not the case that the private household is consuming more and thereby stabilizes goods demand and GDP is up in year 1. This is not the case. And therefore, we call this kind of behavior Ricardian equivalence, and the main message is that it doesn't matter whether the government is running a government budget surplus or a government budget deficit, because the private households will counter the behavior of the government. If this is true, then we can forget all what we learned about expansionary fiscal policy in the form of increasing government spending or decreasing taxes. It will not unfold the effects which we talked about. If the Ricardian equivalence holds, even a long sequence of deficits and associated increases in government debt are no cause for worry. The government is dissaving and the private households are saving in anticipating of higher taxes in the future. Total saving is unaffected, and so is investment or consumption, and the main message of the Ricardian equivalence is deficits and debt are irrelevant. So frequently when it comes to government budgets and government budget deficits, it's the case that you'll run into this Ricardian equivalence argument. I personally don't believe that this relationship holds, but it is the case that you need to know what is behind this argument, because really frequently you run into this argument. In the textbook, you get one figure, figure 22.3. It talks about the Ricardian equivalence, but then you get the ECB interest rate on deposits. I don't know. I think that these two pieces are completely unrelated. Like the ECB interest rate on deposits has nothing to do with the Ricardian equivalence. So this is another mistake in the textbook. So in part 22.3, we talked about the Ricardian equivalence. And in case that the Ricardian equivalence holds, then high debt is not a danger. So government debt does not matter at all. But in this subchapter 22.4, we assume that the Ricardian equivalence does not hold and that government debt comes with some dangers. This is motivated by looking at the increase in European bond spreads for two countries, Italy and Spain, in the year 2012. In order to interpret these kind of lines, it is important to know what a spread is, and this is defined on the next slide. The spread is a difference between two interest rates measured in basis points, like 100%. In this graph, you can see the spreads on Italian and Spanish 2-year government bonds over German 2-year government bonds. And these spreads increased sharply between March and July 2012. Once more, how are these lines computed? Like we take a Spanish 2-year government bond, and we have the interest rate series of this Spanish 2-year government bond, and then we subtract the interest rate of the German government bond, also 2 years period. And this difference was always positive, but sharply increasing in the first half of 2012. And this indicates that the Spanish government and the Italian government, they had to pay a kind of penalty because of the fact that the investors believed that there is a higher default probability for Italian bonds or Spanish bonds, or the investors believed that these countries will leave the Eurozone, and then the liquidation value would be lower. So you can regard a positive spread like a kind of penalty because of the fact that these bonds are assumed to be riskier compared to German government bonds. So in July 2012, the interest rate of Spanish bonds was by 6.6 percentage points higher compared to German bonds. So the spread was equal to 660 basis points. After Draghi stated that he would do whatever it takes to prevent a breakup of the euro area, the spreads decreased. So the famous talk took place in July 2012, and you can see here that the spreads decreased afterwards, and some economists believe that this is due to the fact that Draghi was giving this speech at this point in time. So in the following, I would like to highlight by using one equation which we derived already, what it means in case that the spread increases so much. So we will work with this equation, and in this equation it is the case that we are having on the left hand side the increase in the debt to GDP ratio. And this is driven by the following variables on the right-hand side. Let's come up with a numerical example. Let's assume that one economy has a 100% debt to GDP ratio. The growth rate of GDP is assumed to be 2%. The real interest rate is assumed to be 3%. And the big question is, how large has the primary budget balance in relation to GDP be in case that the debt ratio should be constant over time? So you have all the ingredients you need to answer this question. In the first step, we should use the information that the debt ratio should be constant over time. This implies that the left-hand side should be equal to 0. Then we can insert this information on the left-hand side. This is the first step. In the second step, we can use the information that the growth rate of GDP is equal to 2%. So G is equal to 2%. The real interest rate is equal to R is equal to 3%. And the economy has a 100% debt to GDP ratio. So this ratio here, b t minus 1 over y t minus 1 is equal to 1. Let's insert this information. R is equal to 3%, G is equal to 2%, and this term here is equal to 1. So you can see here the real interest rate, 3%, growth rate, 2%, and the debt to GDP ratio is equal to 1. Let's plug in the numbers we have. Then we know the answer. So the last term here, G minus T over Y, has to be equal to 1%. It is the case that the government has to run a government budget surplus of 1% of GDP so that the debt to GDP ratio does not change. This is the answer to our question. How large has a primary budget balance in relation to GDP be in case that the debt ratio should be constant over time? So the primary budget balance has to be 1% of GDP. Let's assume that a shock happens. What happens if the interest rate increased by 3 percentage points? This was the case for Italy in the year 2012. So, how does the answer to this question change in case that the interest rate is not 3%, but by 3 percentage points higher, so that the real interest rate is equal to 6%? Let's compute this once more. Of course, the primary budget balance has to be equal to minus 4%. So the government has to run a government budget surplus of 4% of GDP. And how can the government achieve that? It can, of course, now, after this shock occurred, increase the taxes by 3% of GDP, or decrease government spending by 3% of GDP, or a combination. For example, the government could increase taxes by 1.5% and decrease government spending by 1.5%. So what the government has to implement here is a contractionary fiscal policy. But what are the consequences of this contractionary fiscal policy? What are the consequences for the interest rate and the growth rate in case that the government implements this kind of contractionary fiscal policy? The investors will get more nervous whether the government could opt for a default. And this would increase the real interest rate once more. And the economy will also end up in a recession, so that the growth rate of GDP will decrease. What does it imply for our equation? The real interest rate will increase even further, and the growth rate will decrease even further. So we have a vicious cycle of increasing real interest rates and decrease of the growth rates, and then the government has to cut back even more. And this vicious cycle is, of course, a high risk to the economy we are looking at. At the end of this vicious cycle, it might be the case that the government finds itself unable to repay the outstanding debt, and it might decide to default. Then the government might perform a haircut and could say, for example, I'll only pay 50% of the debt outstanding. So haircut, this is a percentage that creditors will not receive compared to what they were owed. The default also comes under different names. So government are very creative and coming up with new terms in order to avoid the label default. Governments call this kind of behavior debt restructuring or debt rescheduling, or private sector involvement. Great, so thank you very much so far. In the next part of the lecture, we'll make a big step away from what we have learned so far, and we will talk about money financing. This is a big difference compared to how we approached this question about government deficit, increasing debt to GDP ratios so far, because previously we said we normalized the goods prices to 1 and we assume that the inflation rate is equal to 0, so that money financing was not an option at all. And now in the last subsection, we'll also talk about money financing, where the government can finance government spending by printing money. We call that money financing, debt monetization, or fiscal dominance of monetary policy. So the government will not directly start printing money, but it comes in the following form. The government issues government bonds and then forces the central bank to buy these bonds in exchange for money. So it's still the central bank which is printing money, but the central bank is printing money, giving this money to the government, and the government will issue government bonds. By this procedure, the government is able to receive revenues, and we call these revenues seigniorage. Seigniorage is defined as the revenue in real terms that the government generates with money creation. So here you can see a delta H, a change in the monetary base. This occurs in case that the central bank is printing money, then the monetary base changes. And we divide by the goods price because it is very important how many bars of chocolate the government can get for this increase in the monetary base for the amount of printing money. What is very important is how many chocolate bars does the government get, because the government wants to pay the wages for policemen, for teachers, and for soldiers. And there it is very important that we know how many chocolate bars can we afford for the additional money created. So also here we are working in real variables. In the following, I would also like to modify this equation here so that we can gain more insights into this relationship. So let's modify equation 18 a little bit. We multiply through the right-hand side by 1 in the form of h over h. So we are multiplying here the right-hand side by 1, but not a normal one, but in the form of h over h. When we change the order of the terms, so we put this h on the left fraction and p in the denominator of the right fraction, we get to equation 20. Once more, this is equation 20. Then we divide this equation by GDP and we get to equation 21. So we are dividing here the left-hand side by y, and we are also dividing the right-hand side by y. Now it is time to interpret this relationship. So let's assume that the government wants to finance part of its government spending by seigniorage, and the government has to print some bonds, forces the central bank to buy the bonds. So the central banker prints money so that the monetary base increases, and this has a positive effect on seigniorage. But it is also the case that money creation could cause inflation. If inflation occurs, then it is the case that a positive inflation rate reduces money holdings of the private, so that H divided by P, money holdings decrease, and this has a negative effect on seigniorage. So the government is printing bonds and forcing the central bank to print money. This has a positive effect on seigniorage, but then inflation occurs and the privates hold less money, and therefore this term decreases. So we don't know what happens to seigniorage, whether the government is able to finance its operation by printing money. Of course, one idea is that the central bank has to print money at a higher rate, so this will increase even more, but then it will be also the case that money holding decrease. So it might be the case that we end up in a vicious cycle of printing money and inflation, and in the end the economy could end up in a phase of hyperinflation. This is the last insight of this chapter 22. You can see already here that fiscal policy and monetary policy should not be regarded in isolation. So in the last part of this chapter, you can see that there is a linkage between fiscal policy and monetary policy. This is to some extent new, because in all the other part of the chapter we were exclusively focusing on fiscal policy. But here you can see already that the two macroeconomic policies are related to each other. Therefore, I think it's a good idea to also have a look at chapter 23, where we will examine monetary policy once more. Structure of the chapter will be the same. So we are looking at monetary policy, what we know already, and then we'll also have a look at some new relationships which are linked to monetary policy. Thank you very much for attending this lecture. Thank you. Have a great day. Bye-bye.